No thoughts. Draw a circle. Circles and dots. I like that idea. Circles and dots. So 7 pi's over 3. What do we need to divide pi into? 3 pieces. Pi divided into thirds. So there's 1, 2, and 3 sections on top. And I'm going to do the same thing on bottom. So I get 1, 2, and 3 sections on the bottom. So where does 7 pi's over 3 fall? First quadrant, yeah. So I'm going to draw my angle. There's my initial side. And I would count 1, 2, 3, 4, 5, 6, 7. Goes right here. And again, so it's just drawing the angle and figuring out where it lands. Well, that is a point on my unit circle, pi over 3. If you were to drop an altitude, can you imagine, are those legs the same size or different sizes? They're different sizes. So we've got a short leg and a long leg. So what is this ordered pair then? One half and radical 3 over 2, okay? So it's important to be able to visualize that because it's much better than trying to memorize something. So I can certainly know, hey, it's not a pi over 4. All the pi's over 4 or 45, those legs are the same length. Those get the radical 2's over 2's. Otherwise, we have short leg, long leg. So what is the sign at this point here? Radical 3 over 2, radical 3 over 2. Cosine sign. All right, same thing here. We'll do some circles and dots. What does this mean, the negative? Going in the opposite direction. Good. And so we need to take pi and divide it into what? 2 pieces. So right here, this is pi over 2, 1 pi over 2. Do the same thing on the bottom. But we're going in the opposite direction. Whoops, that was not straight line at all, but that's okay. So we're going to open, and how many times am I counting? 2? 7, yeah. So 1, 2, 3, 4, 5, 6, 7 puts me straight up here at what ordered pair? 0, 1. So what is the cosine at negative 7 pi over 2? 0. Okay. So given an angle, draw it. You guys are excellent at drawing your angles. I think this is my banner year, finally, after teaching this class for 20 years. I think you guys really caught on to drawing angles, dividing up pi, and drawing those, so you're good at that and counting them out. And now we're just putting it all together. All right, we've got a little bit here. This is it. Example 1, find the value of the remaining trig functions using the given information. So you're going to have lots today where it's literally just drawing circles and dots, finding that ordered pair from your unit circle. And then here, conditional trig information. So find the value of the remaining trig functions using the given information. So this is, again, what we did yesterday, just sort of re-solidifying. Okay, so the first thing here, cotangent of some angle is 3. That is some trig information, and if they're giving me a trig equation, then I can draw a related triangle. They're also telling me that sine of that angle is less than 0. They're giving me 2 bits of information. One is sort of vague, but it's telling me that the cotangent of my angle is positive 3, is greater than 0. And they're also giving me this piece, which is really straightforward. The sine of some angle is less than 0. What do we need to do to figure out, what do we need to do with those two pieces of information? Find the quadrant. That's exactly right. So this is what we did yesterday. When they tell me that the cotangent of some angle is 3, that angle can actually be drawn in two different places. Okay? And so we have to figure out, well, where is it supposed to go? And that's what this second bit of information is. So I'm going to go ahead and just draw my ordered pairs signs here. Positive, positive for quadrant 1. What's quadrant 2? Negative, positive. Quadrant 3? Negative, negative. And quadrant 4? Positive, negative. Okay. So let's start with sine because that's a little bit easier. The sine of the angle is less than 0. That means we want to know, where is it negative? So where is sine negative? Bottom 2. Yeah, right here. Sine is negative in quadrants 3 and 4 below the axis. So quadrants 3 and 4, sine is less than 0. Now what about cotangent? This is saying cotangent of my angle is greater than 0 or positive. Where is cotangent positive? 3 and 1. Very good. How do you find cotangent? Using ordered pairs, sine and cosine. Cosine over sine gives us cotangent. So this would be positive divided by positive, which is going to give us a positive result. Same thing here. Negative divided by negative is going to give us a positive result. So cotangent is positive in quadrant 1 and 3. So where should I draw my triangle? In quadrant 3. That's what they have in common, okay? So I can do that. I can draw my angle theta in quadrant 3. So quadrant 3, whoop, my angle goes all the way around here like that, roughly. So there's my angle theta, and what do I need to do? Drop an altitude. Yes, we drop altitudes all the time. When I drop my altitude, it always goes back to the x-axis. Oh, I don't know what accent that was, but that's okay. And when I do that, it creates my little reference angle or reference triangle, which now I can give labels to, like opposite and adjacent and hypotenuse. So now I can use this information about my triangle. They're telling me the cotangent of this reference angle is 3. Just 3? 3 over 1. Very good. What does cotangent tell me? Adjacent over opposite. Very good. So my adjacent side is 3 and my opposite side is 1. Is that correct? No, what should they be? Both negative. Very good. Because our x is going to the left and that be negative x values, we want to assign it with a negative. Because this leg is dropping down, it should also be negative in the negative y territory. We're going to find our radius. What do we know about the radius of these triangles? Always positive. Always, always. So we can go ahead and find that. I'm just going to erase, give myself a little more room here. All right. So I have negative 3 squared plus negative 1 squared equals the hypotenuse or radius squared. Remember, when you're squaring these, negative 3 times negative 3 is positive 9. Negative 1 times negative 1 is positive 1. So we get 10 for our radius squared, which means r is radical 10. And it is always positive. Man, we got to find all 6 trig functions. Oh, Jesus. Out of space. Okay. All right, let's see. Here, green. Ah, all right. Well, let's see. Sine, let me write it over here. According to my angle, cosine. You know what? Can I just do the 3, the big 3? Yeah? Okay, let's just do that. So sine, according to my angle or reference angle, the sine ratio would be Negative 1 over radical 10, opposite over hypotenuse. So negative 1 over radical 10, which then rationalizes to be negative radical 10 over 10. Bueno. All right, cosine, according to my angle theta or reference angle theta, would be adjacent over hypotenuse, negative 3 over radical 10, negative 3 over radical 10, which would rationalize and become negative 3 radical 10 over 10. And then tangent, negative 1 over negative 3, which is 1/3, which we also got just by the reciprocal of what was given to us. And so that makes nice sense. That's a good double check to make sure you did things right. Okay. So same idea over here. They're telling me that the cosine of some angle is negative 2/3, which would imply that the cosine of the angle is less than 0. Good information, less than 0. That's not theta. Then we also know that the tangent of that angle is less than 0. What quadrants is cosine less than 0? Quadrant 2 and 3. Yeah, quadrant 2 and 3. So cosine refers to the x values. And so x values are negative over here to the left. So quadrants 2 and 3. All right, where is tangent less than 0 or negative? Yeah, 2 and 4. That's where our signs are different. That's going to give us a negative result. So that's quadrants 2 and 4. So where should I draw this triangle? Quadrant 2. Good. So in quadrant 2, there's my angle theta. What do I need to do? Drop an altitude to create my reference angle. Reference angle between the terminal side and x-axis. Always less than 90 degrees. It's the reference. It's the reference for our labels here. Cosine is adjacent over hypotenuse. So a 2 and a 3 for the adjacent and hypotenuse. Where do I put the negative? With the 2. Very good. So watch those signs. Make sure you're putting the negatives where they deserve to be. Okay. All right, I'm going to go ahead and find this other side. I'm going to call it y, just because it's vertical. Negative 2 squared plus y squared equals 3 squared, hypotenuse squared. That's going to be 4 plus y squared equals 9, which means y squared equals 5, and y must equal plus or minus radical 5. What are we going to take? Plus positive radical 5, because we are in the positive y direction, going up. All right, very, very good. Now that we have those labels, what is the sine according to theta and the cosine and the tangent? Oh, I already have the cosine. That's good. Let's make sure it's right. Adjacent over hypotenuse. Yes, our picture is good. Always a good double check there. What's the sine going to be? Radical 5 over 3. Yes, not what I wrote, but what I said. Okay, radical 5 over 3. And the tangent's going to be? Yeah, radical 5 over negative 2 or negative radical 5 over 2. Good. You guys have any questions for me? All right, cool. Putting it all together, we are done. You guys have a test on this stuff on Monday, since I pushed it back because